So we are beginning our revision, and I want to handle it chapter by chapter. I pick a few things. I hope that by the time we are done with the last lesson, we'll have had the opportunity to look at everything, the main picks. So to start off, let's go to, so we are dealing with chapter 1. We want to look at chapter number 1. And the first question that I want us to attempt is November 2015, question 1B. November. (2015), question 1B. I hope you are there. November 2015. If you're there, the question says, a company is considering whether to purchase equipment to increase its production and sales volume. The equipment costs shillings 500 million and has a useful life of 3 years, after which it can be sold as scrap for 80 million. For each of the 3 years of usage, for each of the 3 years of usage, I think there should be a comma, the equipment is expected to increase both sales revenue and operating costs by shillings 600 million and 390 million respectively. The company's cost of capital is 10% required. Compute the percentage change required in each of the following factors for the project to be rejected: initial cost of the equipment, scrap value of the equipment, sales value. Yeah. So what you need to know, number one, is when you're told to judge whether it will be rejected or accepted, you can start by saying at indifference point. At indifference point. At indifference point, the present value of cash inflow should be equal to present value of cash outflow. That is, NPV should be 0. Maureen, how are you?
I'm good mwalimu, kwaje?
Niko poa, karibu sana.
Thank you. Ndio mmeanza?
Ndio tunaanza.
Oh, sawa.
So that is how we go about it, or the point of indifference. So we are told here that the initial cost, the present value of the cash outflow, that one we know is 500. Then the other one is the annual increase, the annual net cash flow. Margaret, how are you?
I'm fine, thank you.
Karibu.
Thank you.
So the annual net cash flow we are told that we will have an increase of 600 and an increase of 390 in terms of the costs. So the inflow there will be so start sending your answers now. $210. So this is an annuity. So if it's an annuity, we have to get the present PVIFA at 10%. That is the cost of capital. 10% for 3 years. So go to the tables and read that. Or alternatively, you use the formula. Go to the tables and read that. Or you want to use the formula? If you want to use the formula will be 1 minus 1 plus 0.1. You raise power minus 3. You divide by 0.1. Peter, I think umeisoma vibaya. 10% for 3. It should be 2.4869. 2.4869. Peter, are you able to see the correct one in the table? Okay, so we have the salvage value. The salvage value. So the salvage value we are told is 80. Then we need to get the present value interest factor again at 10% in 3 years. This one now you are looking for the SIGO cash flow, not the annuity, the SIGO. So read that from the table or you use this formula. 1 plus raised power minus 3. Yeah, 0.7513. 7513. So with that now, we are able to get the present value of the cash inflows. The present value of the cash inflows, it will be, tuko na ile 210, you multiply by 2.4869, you add this 80, you multiply by 0.7513. 13. Wasa? Wasa? 582.353. The present value of cash outflow, this is 500. That is the cost of the project. So the NPV should be 582.353. You minus 500, and this now is 82.353. And therefore, we will advise that you accept, since NPV is greater than 0. You should accept that because NPV is greater than 0. Now with that, we are told to get the percentage change. So we'll say now, percentage change. If you want to get percentage change of anything, we always say it is equal to the new value minus old value, new value minus the old value. You divide this one by old value times 100. Times 100. The project will be rejected. The project will be rejected if NPV is less than 0. If NPV is less than 0. So let's start with the initial cost of the equipment. Initial costs. Initial costs of the equipment. Initial cost of the equipment. Now, right now, the initial cost is here, this one. So we want to argue like this. 582.353 minus the present value of cash outflow should be 0. That is what we call the indifference point. This one should be 0. And therefore, the present value of cash outflow should be 0 plus 582.353, and this is 582.353. That is the present value. So the percentage change, should be equal to the new value. So the new value is this one. Minus the old value, which is 500. You divide this by the old value, 500. Then the answer you multiply by 100. The answer you multiply by 100. What? 6.47%. So, reject the project. Reject the project if initial cost increases by more than 16.47%. Yeah, so that project should be rejected if the initial cost goes up by more than. If it goes up by more than that, it will create a negative NPV. It will create a negative NPV. The next one is scrap value of the equipment. So let's look at the scrap value of the equipment. The scrap value of the equipment. We are also going to argue the same way. So tukuja hapa kwa hii function hii ya NPV. Actually this one. So this one will require that we take 210 times 2.4869 plus salvage value. Salvage value times 0.7513. We minus the initial costs. Remember, this question is on sensitivity analysis. The question is on sensitivity analysis. So we minus the initial cost, 500, and that should give us a 0. That should give us a 0. That should give us a 0. So I believe you can be able to solve from there and give me the value of SV. Solve that. Yeah, negative 29.614. So the salvage value should go to negative 29.614. So, the percentage change, should therefore be equal to the new value, minus 29.614, minus the old value, 80. You divide by the old value, 80, times 100. Yeah. Negative 137.0, or we can just call it negative 137%. So that means you reject the project if the salvage value, decreases by more than 137%. Now that the sign is negative, that is a decrease. That's a decrease. And finally, sales revenue. So for the sales revenue, now this sales revenue ndio hii iko hapa. So this 210 yenye tulikuwa nayo hapa, this one, we are going to say it is R minus 390. You multiply by 2.4869 plus 80 times 0.7513 minus 500, it should be equal to 0. Should be equal to 0. So now from there, solve and tell me what should be the new value of R. 566.8853. So the percentage change okay, so negative 5.52. Yeah, so just write, and then you just write like we have said here. So reject the project if revenue reduces by 5.5, by more than. Reject the project if sales revenue reduces by more than 5.52%. Okay. The next question I want us to look at is November 2016. Let's go to November 2016. November 2016. November 2016, question 1B. November 2016, question 1B. November 2016, question 1B. November 2016, question 1B. SKB Limited is considering a proposal to manufacture a new drug named Millennium. The drug will be manufactured using a machine which will cost shillings 13 million. The cash flows and drug life relating to Millennium have been estimated as stochastic exogenous variables with the following distributions. The minimum required rate of return from this investment is 16%. The company has approached you as a financial management expert to perform an analysis of the above project. Using the following random numbers, perform 10 simulation runs on the NPV. Okay, now you know when we are dealing with simulation, the first thing is to get the Monte Carlos. So we will get the Monte Carlo for the annual after-tax cash flow. So let's start here. The Monte Carlo for the annual after tax cash flow. For the annual after tax cash flow. So we will have the shillings. We will have the probability. We will have the cumulative probability. And then we'll have the range. Yeah. So the shillings are beginning from 1,000 to 4,000 with a gap of 500. Yeah. Up to there. Then we need to do the Monte Carlo for drug life in years. Monte Carlo for drug life in years. For drug life in years. So here we have the years. Here we have the probe. We have the cumulative probe. And then we have the reach. Oh, it's time for prayers. Okay. So we can allow Abdara. 10 minutes. Thank you. So we pick up from there. Good. Let's continue now. So the probabilities are 2, 3, 15, 15. Uh, 3, 2, 15. Cumulative probability, I believe everyone knows how to cumulate. Now, what I need to remind you is maybe how to get the ranges. Remember now that these are two decimals, you multiply by 100. So those are 2 digits. So unaanza hapa 00 to stop at this number, less 1. So to stop at 1. From 1, you go to 2, all the way to 4. From 4, you go to 5 to 19. Then 20 to 34. 35 to 64. 65 to 84. 85 to 99. The years 3, 4 to 10. 3, 4, 5, 6, 7, 8, 9, 10. Probabilities are 5, 10, 30. Uh, 25, 15, 10. Uh, 3 and 2. Probabilities cumulative 0.05, 0.15, 0.45, 0.70, 85, 95, 98. Cumulative, this is 00 to 04, 05 to 14, 15 to 44, 45 to 69, 70 to 84, 85 to 94, 97. Yeah, so kutoka hapo now, we are supposed to design the sheet. We are supposed to design the sheet, the simulation sheet. The simulation sheet. Now, as you design, you always need to identify where are you headed? What is your objective? The objective is to get NPV. Is to get NPV. So how do we compute NPV? How do we compute NPV? We know it is the present value of the cash inflows minus the present value of cash outflows. We get NPV. So the distinct items that we require to get the cash inflows on its own. We require to get the PVIF factors so that we get the present values. We also require to get the cash outflows. The cash outflows. Yeah, I think those are the things that we require. The things that we require. So if that is what we require, I design namna hii. We are going to have run number there. Then we have after tax cash flows. So annual after tax cash flows. So we have the random number. We have the shillings. So this one we can just call it cash inflow. Cash inflow, CIF. Cash inflow. Then we will have life in years. So we have the random number. We have the years. This will be our N. Then we will need to get these will be annuities. These will be annuities, eh? So we need to get the PVIFA. And this one we are getting it at the cost of capital is 16%. So at 16% for N years. For N years. For N years. We may not need to draw the, maybe I can put, well, it will be a lot of repetition. The present value of cash outflow, we can squeeze it there. Then net present value. Net present value. Net present value. So net present value will be the cash inflow times present value factor minus present value of cash outflow. That way. So as I wait for you to finish, I can be decorating my book here. Maliza kuchora, sema okay. For you, you don't need to draw these lines. Your book is already ruled. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maliza sema okay. I'm saying when you are done with the drawing, you say okay. Okay. We are okay now. So let's begin. Let's begin the analysis. So random number one, you pick the first random number. The first random number is 53. So tell me 53 hapa inaleta how much? Kwa hii Monte Carlo ya cash flow. 53, it qualifies for how much? Kila mtu aandike nione kama tuko pamoja. Abdara. So I can see we are talking of 3,000. Good. I take the next random number, which is 97. So 97 is how many years from there? 9. Naona tunaelewa, so we can move faster. Now go to the tables, fungua tables, uende kwa column ya number 16, 16%. Unisomee 9 years. 9 years, row 9, column 16%. Nisomee hiyo value, the PV. No, we want the, Maureen, we want the annuity. This is an annuity. This is an annuity. Ukiona iko na A, that's an annuity. So 4.6. 065. Is an annuity. Is that clear, Maureen? Good. So the present cash flow is the cost of that project. The cost of this project, we were told it was 13 million. So it is 13 million here. So 13,000. So with that, multiply. Work out and give me the net present value. Yeah. It is supposed to be, you take these 3,000 times these 4 minus 13,000. Peter, so that you get 819.63. Peter, umeiona hivyo? Okay. Haya. So let's go to the next one. The next one, the random number is 66. So 66 ukikuwa hapa is giving us how much? $3,500. You go to the next random number, 99. So 99 will give us how many years? It will give us 10 years. Now go to the tables, unisomee the PVIFA for 10 years at 16. $4.8332. So the cash outflow is still 13,000. That one is not changing. It's not a random variable. So sasa work that out. Uniambie NPV. NPV. Uchukue hii 3,500 times this 4.8 minus 13,000. That 916.2. Let's go to number 3. The random number is 30. So tell me 30 would qualify for a cash of how much? $2,500. Then the next random number is 81. 81 is how many years? Seven years. Haya, go to the table, usome the PVF for 7 years. $4.0386. Haya, this one is 13,000. So 2,500 times 4.0386. Negative 2903.5. Next is year 4 or round 4, where we have 19. So 19 is giving us the cash flow of how much? $2,000. So 19 at 09. 09. That would be how many years? Four years. Nisome the 2.7982. 13,000. Negative 7403. Oh, ni 0.6. 0.6. Now, I am thinking that at that point, the point is well understood, no much value being added now. You can be able to complete on your own the other runs. Is that so? You can be able to complete on your own. Say my yes. Yes, Peter. Yes, Maureen. It's Margaret. Abdara, are you still there? So the only thing you shall do extra, ukishamaliza the 10 runs, you add these total, you add all of them, you get the total down here. Then you divide by 10. You add, you divide by 10. And that will be the answer to Roman 2. That will be the answer to Roman 2. It will be the expected value. So if that is well understood, I want us to attempt another question here. June 2008, question 4B. Let's rush there. June 2008, question 4B. So with this one, ukipata swali ya simulation, I believe you'll be able to handle comfortably. So Josephat, while you are away, we have agreed that you complete the question on your own.
Okay.
For the remaining runs, then utatafuta total ya NPVs. So your total you divide by 10.
Okay.
Yeah, that would be the answer to Roman 2.
All right.
So we are now looking at June 2008, question 4B. June 2008, question 4B. In that question, we are told MobileNet Limited is a company operating in the telecommunications industry. The company intends to invest in an equipment that would facilitate. Hebu endelea kujisomea hiyo swali as I respond to a call here. Sorry for that, but I believe umemaliza kujisomea. Na kama umemaliza kusoma, then you can see clearly we are told to use the decision tree. And I told you, when you are told to use a decision tree, the first thing is to know the options. Options is what the decision maker can control. So in our case here, these guys can decide whether to delay or not to delay. That is an option available to them. Now, whatever they do, there will be three possibilities. Or rather, after you have known the options, you go for the outcomes. The outcomes are beyond control. The outcomes are beyond control. So that means we are going to have 6 tails. We are going to have 6 tails in our tree diagram. Now, the next thing ni kujua which items will be put where. And as I've told you, you start from the end result. We want to get expected net present value. That is what they are saying. They want expected net present value. So how do we get expected net present value? It will be the sum of the net present value multiplied by the probabilities. So as per this one, we will need the present value on its own. We will also need the probability on its own. Higher. How do we get NPV? NPV is the present value of cash inflow minus present value of cash outflow. That's how we get NPV. So the distinct or the elements in this formula, the elements, you will require the cash flow, the cash inflow. Obviously, you will require time. You will require the time. That is N. You will also require the PVIF. You will require the PVIF. We also require to know R. For us to get the PVIF, we need N and R. So these three, we can combine them as one. Because we know PVIF or PVIF-A is brought about by N and R. Then this one, we require the cash outflow. The cash outflow. So which items do we require? We require the cash outflows, we require this one, we require this one, we require NPV, we require the probabilities. So that now we are able to get the NPV. That's how you argue, so that you're able to know utaipanga namna gani. So ukishajua hivyo, you now come to the end of your page. Unaenda where your page ends. Now, where our page ends, I will need expected net present value. That will be my end. I will need the probability. I will need the probability. Who else will I need? I will need the NPV. For me to get NPV, I will need the present value of cash outflow. I will also need the present value of cash inflow. Oh, what else do I need? I will need the PVIF. And I will need the cash flow. And I will need the cash flow, the cash inflow. The cash inflow. These are the items we have identified. I think nimechukua zote. The NPV iko, NPV, probability, cash inflow, the PVIF, the cash outflow. Yeah. So sasa hii space hii ingine imebaki ndio nitachora my decision tree. This is where I will have my decision tree, which I already know it has 6 tails. I already know it has 6 tails. So tulisema we need 6 tails. So 1, 2, 3, 4, 5, 6. So this will be the end of my tree. Options are drawn like this. So as you finish, I can also be decorating my book again here. Haya, sasa the first one is when you begin 1st of January 2009. So no delay. So if there is no delay, you begin on 1st of January 09. Then here you can delay so that you begin on 1st of January 2010. And then we have 3 states. This is high, this is average, and this is low. This is high, this is average, and this is low. The probabilities are 25, 0.25, 0.50, and 0.25. 0.25, 0.50, 0.25. The cash inflows, the annual cash, this is 82.5, 62.5, and 12.5. 82.5, 62.5. Those are the cash flows that are given there in the question. So ukifika where I am, sema okay, ndio tuanze safari from there. Oh, good, we are there. So if we are there, I would like you to go and read the PVIF at 12%. It is 12%. And so this one utasoma for 3 years. The first 3. Easy. Utasoma for 3 years. Nisomea 3 years. And this PVFA. These are also annuities. These are also annuities because they are constant. So nisomea 3 years. Haya, 2.408. So hiyo unaweka hapa 2.408. 2.4018, 2.4018. But for these others, utasoma ya 2 years. Wakisha delay, there will be 2 years. So nisomea ya 2 years hapa. Ya 2 years, 1.6901. Yeah. The present value of the cash inflows. So multiply now this by this. Ya kwanza. Multiply. $198.14. 198.1485. Haya, hii ingine multiply. Let's try to move a bit fast. Aha, 150.1125. Next. We are just multiplying these cash flows with the PVIFAs. 30.02. $225. Next. Those Meshkana Abdara. Is it 139? $139.43325. Next. Oh, 105.63125. 63125. Next. 21.1263. The present value right now, if you implement this project right now, walikuwa wamesema it is going to cost 125 million. So hapa ni 125 million. But here hapa, this one, we will have a working. So you can have a working down there. Workings. So the present value of the cash outflow for the delay, you will have to discount it. You will have to discount it. You will take this 125 multiplied by 1 plus, we are using 12 raised power minus 1. You will have to discount it because tumeulizwa saa hii. So kama hiyo 125 ndio tutatumia 1 year from now, we need to know how much that money is today. So that one will be discounted. So nimetumia formula, but you can also read from the table. So 1, is it 607 or 613? 111 ama inategemea na 111 inategemea na nini? 61. So let's just confine ourselves to 61. 11.61. 11.61. Haya. Tuende kwa NPV now. NPV unachukua this one, una minus this one. The present value of the inflows minus the present value of the outflows. $73.14. Space yangu inakataa, so I will just ignore the decimal. Let's ignore the decimals. Let's ignore the decimals. We round up or down appropriately. But kama ama now that tulikuwa nayo. Naona hizi decimals tasubua. Haya, tusonge tu without them. But in the exam you can use them. Haya, so the next one is 25. Okay? Haya. The next one is negative 94 or 95? Negative 95. Negative 95. The next, you round up or down appropriately. The next, 27. The next, 28. Is it 27 or 28? Let's go with 27. The next one, negative 6. The next, the last one, So negative 90. So probability ni hizi tu ziko hapa. So 0.25, 0.5, 0.25, 0.25, 0.5, and 0.25. Haya, so let's multiply this times this. $18.25. So these ones are not many, we can recognize them. Next. Next is 12.5. Next, negative 23.75. Next, $6.955. Next, 3 is negative 3. Next, $22.5. So that is you need now our tree. What else? We are told to get the expected net present value. So takuja sasa hapa chini, we already have the workings, tulikuwa tushasema workings. So let's start with the option of no delay. If there is no delay, the first thing is the mean. Now remember, the mean, the expected net present value, or let me just use the general formula that we use. The expected value of x is the sum of the xi's multiplied by the probability of xi. So in our case now here, we already have, these are our xi's, these ones, and these are the probabilities. So we already have multiplied. So we'll just say it is 18.25 plus 12.5 plus negative 23.75. This is our mean, and that is the expected net present value. You add them. $7.1. Okay, so if that is the case, the next thing, so this is now what they are calling the expected net present value. That's what the examiner is calling the expected net present value. You're here. So the next thing the examiner wants is the standard deviation is the standard deviation. Standard deviation. And you remember very well that standard deviation, we normally get it as the sum of the xi minus x bar square, probability of xi. You get the square root or you raised power half. You get the square root or you raised power half. So sasa hii ama nitumie tu hii space ndio isisumbue. So I will start by opening the bigger brackets, then I open the smaller one. So the xi is 73. So 73 minus 7.1, you square, una multiply na hii probability 0.25. Plus, you open the brackets, the next xi is 25 minus 7.1, you square, times the probability is 0.5 plus the next one is negative 95 minus 7.1, you square, you multiply by 0.25. Then you get the square root. You get the square root. You get the square root. I'm waiting for the answer. Six, 2.13. Yeah, so thereabout. So coefficient of variation. Coefficient of variation. Coefficient of variation. Coefficient of variation. So CV is given as standard deviation, you divide by the mean times 100. So this will be 62.13 divide by the mean, which is 7.1 times 100. %875%. 875%. Higher. You will do the same things now for delay. For delay, we can now just go straight. The expected value of x, it is unachukua hii sasa 6.955 plus minus 3 plus minus 22.5. Negative 18.545. So standard deviation, it will be 27 minus 18.545. You square, you multiply by 0.25 plus minus 6 minus 18.545. You square, multiply by 0.5 plus minus 90 minus 18.545. You square, multiply by 0.25. You get the square root, or you raise to power half. Let's move very fast. Masaa mengine ndio tunakula sasa. Naona washaanza kuingia. Now 43, I have a slightly different one. Someone else to give us, tuone. Okay, so we are in agreement. 43.504. Or something thereabout. So let's get the CV. So the CV utachukua hiyo 43.504, you divide by the mean. The mean is negative 18.45 times 100. Jaribu kukimbizana na hii time. So decision criteria, we have delay, no delay, so option taken by a risk neutral, risk taker, and risk averse. So tulisema we have three decision makers. We have three decision makers. We have a risk averse, we have a risk taker, move very fast, move very fast. Tuko kwa masaa ya wenyewe sasa. Tuko kwa masaa ya wenyewe. So hapa ukitumia the mean, standard deviation and the CV. Hii ya delay, the mean is 18.545. Standard deviation is 43.504. Hii ingine ushanipea jibu. Minus 235%. Haya. CV hapa tulikuwa na 875%. Standard deviation, this was 62.13. And this was 7.1. So sasa, risk neutral uses these ones. So he will go for the higher. So he will choose no delay. You will choose no delay. Risk taker hatumii hii. He does not use. Risk taker tukikuja hapa kwa standard deviation, atachukua the higher. This one. So he will take no delay. Na akitumia hii, he will also take no delay. No delay. But risk neutral, risk averse, anaendanga kwa ile dogo. So he will take the delay. And even here, he will take the delay. Yeah. So sasa, umeona where we have begun. if you want these blocks to help you more, sasa urevise kuanzia topic 1 mpaka hapa mahali tumefika. Yeah, revise your topic 1. In other words, sasa revise topic 1 ndio kesho tukipatana tumalizie the other bit ukuu unaielewa. So thank you very much. I believe you have copied. I want to end the lesson so that the others can join. Nilikuwa nimewaambia wa join at 8:10. Mkura dakika zao 13. Thank you very much.